Hello everyone, welcome to this session. Our topic is current electricity. The past video discussed about Ohm's law. We saw the concept of Ohm's law, how the Ohm's law triangle works. So let's today discuss about building simple electric circuits. Specifically, we are going to see the combination of resistors. So let's dive into it. Uh, When you talk about combination of resistors, this is just other kind of connection of components within a circuit. Now, there are two main methods of connecting circuit components, which are in series and in parallel. So simply you can connect your various circuit components like a bulb, the ammeter or voltmeter, the resistors, and so on and so on, by using these two main methods, series or parallel. But there are other kinds of methods. Take an example, combined series and parallel, which is just the other kind of connecting the circuit components. So let's mainly discuss about these two series and the parallel. So resistors can be connected either in the following combinations, the series combination and parallel combination. So based into these two kinds of methods of connecting these resistors as one of the components of the circuit. Now let's see the series combination. Now in series combination, in this kind of combination, the current flowing through the circuit is the same throughout all the resistors. Take an example, that's just a simple illustration of three resistors. So the current flowing through these resistors is just the same throughout all these the resistors, while the voltage varies depending on each resistor, resistor 1, resistor 2, and the resistor 3. So you can simply say that the current flowing is equal throughout all the resistors. Now mathematically, you can say that since the voltage varies, so to get the total voltage here, it means you're going to take voltage total will be equal to voltage 1 plus voltage 2 plus voltage 3. This means that you're trying to collect the volts from voltage from this resistor 1, resistor 2, and resistor 3. So it will be voltage 1, voltage 2, and voltage 3. Now from there, we know that voltage total will be equal to current times resistor 1 plus current times resistor 2 plus current times resistor 3. Why has it changed it like this? Because simply since Ohm's law said that V equals to IR, now from there, since V equals to IR, it means that where there is V1, you're going to put IR1. Since current is the same throughout all the resistors, so current will remain the same, but the resistance will vary from each resistors, resistor 1, resistor 2, and resistor 3. So from Ohm's law, V is equal to IR, so V total will be equal to I times R1 plus I times R2 plus I times R3. Now, then we have to know that V total is equal to I times R total. Now, it means where there is V total, we will insert this one, I times R total. Since current is same throughout all the resistors, it means the current from resistor 1 to resistor 2 to resistor 3 will be just the same as the equal current that is flowing throughout this whole circuit. So you can just simplify, or you can just remove these currents from these equations. So what will remain will be equal to V total is equal to R1 plus R2 plus R3. So this is basically the general formula mathematically on how you can obtain the total resistance throughout a series combination of resistors within a simple circuit. I hope it's clear, guys. Moving on, let's see the power combination. Now, in this power combination, it's just kind of reverse from the series combination. That is, in power combination, the same voltage is the one that flows throughout all the resistors. It means that the voltage across uh, resistor 1, resistor 2, and resistor 3 is just the same, but the current is the one that varies. Here you can see that when current reaches here, it splits to resistor 1, resistor 2, and resistor 3. So basically, voltage is the same while the current varies. It's just reverse to the series combination whereby the current was the one that was the same, but the voltage was different. So mathematically, you can say that to obtain the total current, we go to I1 plus I2 plus I3. It means you're trying to collect the current flowing in the resistor 1, resistor 2, and resistor 3. But from Ohm's law, we know that I equals to V over R. So simply, it means that V over R total is just the same is equal to I. So from here, this the first mathematical equation, it will be V over R total is equal to V over R1 plus V over R2 plus V over R3. Since from Ohm's law, I is equal to V over R. So we have just substituted these values in these I's. So I total, it will be V over R total. I1, you just change here where there's R, you just input the values R1, R2, R3, but the voltage is the same. So then we know that from there, you just see that I total is equal to V over R total. Since the voltage is the same, so we consider removing the voltage. So when the voltage is the same throughout all the resistors, this voltage will be cancelled out from both sides. Here, the before the equal sign and after the equal sign. So the V will just be removed. So we just get the general formula that 1 over R2 is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So generally, that's the general equation on how to obtain the total resistance throughout a parallel combination of resistors in a simple circuit. I hope it's clear, guys. We've discussed these two series combination and parallel combination. Moving on further in a parallel combination, we know that when bulbs have to be powered by a single source of electric current, the bulbs are connected in a parallel. This is also practiced in car and the home lighting systems. Now, the advantage of a power arrangement over series arrangement is that first one, that the full PD, that is the potential difference of voltage of source, is applied across each bulb irrespectively of the number of bulbs. And the second one, that switching one bulb on and off does not affect the others, as when maybe you would have tried to connect them in series, switching one bulb would affect the other one. But in parallel combination, switching one bulb will not affect the other one, that might remain turned on or likewise off. So there you have it. Thank you for listening. I hope it's clear, guys. In this video, simply seeing the parallel combination and the series combination of the resistors. Thank you.